In this question, we're asked to use the trapezium rule with 3 strips to calculate an estimate for the area of the region bounded by the curve, the x-axis and the y-axis, so basically the area under the curve. Well, if we were taking 3 strips, we would be then looking at this strip here, strip 1, strip 2, and then strip 3, which is the bit that takes us the curve to the x-axis. In this case, what we've actually got, we estimate that the first strip is in fact a trapezium, the second strip is in fact a trapezium, and the third one obviously a special type of trapezium, which just happens to be a triangle that takes you back to 3 at x equals 3. So the area of the first strip would be, using our rules for area of trapeziums, a half of a plus b times h. In this case, we know that the height here is 9 and the height here is 10, so the sum of our parallel lines is 10 plus 9, which is 19, times by our height, which is the distance along the x-axis here, which is 1. So a half of 19 is 9.5. In our second trapezium, we use the same rule, a half a plus b times h. We know that the height of the first parallel line is 10. The next one is 9. So again, this is a half of 19 times the height, which is 1, distance along the x-axis for that strip, which again gives us an area of 9.5. And finally, we have a triangle of a base of 1 and height of 9. So it's a half base times height, which is a half of 1 times 9, which is a half of 9, which is 4.5. And our next final piece of information is just to work out the total area, which is 9.5, 9.5, and 4.5. Well, 5, 5, and 5 gives us 15. Carry the 1. 9, 9 is 18. Add 4 is 22. Add another 1 is 23. So our overall area is 23.5 units.